Hi class, Mrs. Calvi here. Quick review on simplifying algebraic expressions. So I have here on my screen 7x plus 9y plus 15. Well, the first thing we want to talk about is how many terms an expression has. So in this case, we have 7x is one term, 9y is another term, and 15 is a third term. So this expression has three terms. A term can be either a number, it could be a variable, or it could be a product of numbers and variables. Okay, so if you notice, we have three terms here, and they are separated by operational symbols. So it's pretty simple. You just look to see what is in between your operational symbols, and you count how many terms you have. Now, we also have what we call coefficients. So, coefficients. So, our coefficient is the number located right before the variable. So, in this case, our 7 is the coefficient. We have a 9 as a coefficient. And our number 15 doesn't have a coefficient because we don't have a variable associated with it, okay? This 15 is actually called our constant, all right? It is called our constant, which means it does not have a variable with it, and typically a constant is always located last. That's our constant. Constant is a number that doesn't change, okay? So the value doesn't change. All right, the next thing we're going to be talking about is identifying like terms, okay? So if you see on my page here, I have a box and it says like terms and unlike terms. So in our like terms section here, we have 3x and 2x. Those are like terms. They are the same, okay? So it's like having apples and apples. Here we have w and w divided by 7. And those are like terms. And we have 5 and 1.8. Those are like terms because they are the same. These are just numbers or numerals. All right, so 3x and 2x are like terms because they are alike. It's like apples and apples. W and w divided by 7, those are like terms. All right, both working with a variable of w. And 5 and 1.8 are like terms because those are both numbers, okay? So now for our unlike terms, we have 5x squared and 2x. Because the exponents are not the same, they are not like terms. So 5x squared is not the same as 2x to the first power. So exponents matter here. So right above with the 3x and the 2x, those were like terms because they both had an exponent of 1. Here we have 6a and 6b. Because the variables are different, these are not like terms, they're unlike. And we have 3.2 and n because one is a variable and the other is a number or a numeral. Okay, so here we want to be able to identify which terms are like in the list. All right, so we have 5a, t divided by 2, 3y squared, t squared, x squared, 4z, k, 4.5y squared, 2z, and 2/3 a. So if you notice what they did here, let me see if I can make it a little bit larger. Okay. So you see that they kind of color-coded and used shapes. So the red oval, those are like terms. So 5a and 2/3 a, those are like terms. So we can put those together technically. It's like having apples and apples. We can actually add those together if we wanted to. The next like terms are t divided by 2 and 2t. Even though they're different operations, they are like terms. We can technically put them together if we wanted to. Then we have 3y squared and 4.5y squared. The variables are both y and they are both squared. They have the same exponent, so those are like terms. Okay. Oh, and then I forgot here, the 7t went along with the t divided by 2 and the 2t. All right. These, they did not identify with anything else, so these didn't have any like terms to go along with. So when they listed the like terms, you just list them with the and in between it. But for the homework assignment, you are actually going to do this on your paper that you are uploading, and you're going to kind of do what they did. You're going to either use shapes or color coding to tell me which ones are like terms. Okay? Now, once we have identified like terms, one thing that we are going to start doing is we are going to start combining like terms. Okay? So for example here, they have 4x plus they have 5x's. So because these are like terms, 4x and 5x are like terms, like apples and apples, we can combine them together. We can add them together to get a total of 9x. This is just like when we were talking about positive and negative integers. If we had -3 and -8, we would add those together because they are like terms, like having apples and apples, okay? So let's take a look at combining like terms, or as they're saying, simplifying them, okay? So we have 7x plus 2x. Those are like terms. We can add them together. We would get a total of 9x, all right? Then we get into a little bit more of a more difficult problem. We have a lot going on. We have different variables. We have different exponents. The one thing you have to remember, you are going to put your final answer in descending order of exponent. I'm going to explain that in a second. So I'm going to actually do this problem on the whiteboard just so you can see how it works out. Okay, so I wrote the problem out. So now combining like terms, I'm going to look to see where I have the largest exponent, because as I said, I want to put my final answer in descending, so largest to smallest, descending order of exponent. So I noticed that my largest exponent is a 3. So I have 5x cubed and 7x cubed. Okay, so I'm going to combine those together. So now you also need to know your positive and negative integer rules. All right, so let's go ahead and I'm going to box these in because these are like terms. And I'm going to combine them. So I have a positive 5x cubed and a positive 7x cubed. So you have to think they're both positive. So I'm going to add and keep the sign. So this goes back to our integer rules, okay? So I'm going to add and keep the sign. So when I add and keep the sign, I'm going to get 5 plus 7 is 12. So that becomes 12x cubed, okay? So now I'm going to go to my next largest exponent. So the next largest exponent I see, and if you noticed here, I included my addition sign, okay, making this a positive. So my next largest exponent is -4x squared, or minus 4x squared. Well, I don't have anything to combine that with because there isn't anything here that has an x squared. So now I'm just going to drop this down, and I'm going to write minus 4x squared. Okay, so far so good. So now let's see what other like terms we have. So we have a positive 3y, or a plus 3y, and we have a negative 2y, or a minus 2y, okay? We're treating these as integers. So I have a positive 3y and a negative 2y. Signs are different. I'm going to subtract and take the sign of the bigger number. Well, I'm subtracting the sign of the bigger number. That is going to be a positive because 3 is larger than 2. And I have a positive sign, or a plus sign, associated with my 3. So I am going to drop down a plus sign, and then I'm subtracting 3y minus 2y leaves me with 1y. Okay? Now, one thing you are going to learn. 1y is the same thing as y. We will not be putting the 1 in front of it. You will not see the number there. Okay? So I'm actually going to erase it because we would not be putting that 1 there. All right? Hold on one sec. I don't want to erase all of it. All right, so I would just put it as plus y, and that means plus 1y. If I don't have a number in front of my variable, it's automatically 1. So now I have my final answer as 12x cubed minus 4x squared plus y. So if you notice, my answer is in descending order of exponent, okay? Also, we would also list these in alphabetical order if needed. It just so happens x comes before y, and this landed nicely. All right, let's try another one, combining or simplifying with like terms. Okay, so here I have a lot going on. So I am going to be looking for my largest exponent. Oh, I have an exponent of 2, 2, and 2. So don't know which one. They're all the same, right? But I noticed I have a 2 that's attached to an A, a 2 that's attached to a B, and a 2 that's attached to an A. So as I said earlier, we would also use alphabetical order. So because my exponents are all 2's, I'm going to now go alphabetically. So I'm going to first work with my a squareds. So I am going to identify my like terms. So 3a squared and a positive, remember I take the sign with it, a positive 2a squared, those are like terms. So I'm going to combine those. So positive 3a squared and positive 2a squared gives us a positive 5a squared. Okay? So next, identifying, we don't have any more a's, so now I'm moving to my b's, and I'm going to start with my largest exponent. Well, it looks like I only have a positive 11b squared. I don't have anything to combine that with. So I'm going to drop that down, plus 11b squared. And let's see, I have a positive 5b and I have a negative 4b. Those are like terms. So positive 5b, negative 4b. So I have to think of my integer rules. My signs are different. I'm going to subtract and take the sign of the larger number. So 5 is larger than 4, and 5 has an addition sign, positive, right? So I know it's going to be positive, and now I'm subtracting. 5b minus 4b would give me a 1b, but remember what we said. If it's going to be a 1, we're not putting the 1, we're just putting the variable. So now I have just a constant left. I just happen to have, let's see, I have a negative 6 or a minus 6. I don't have anything to combine that with, so I'm just dropping that down into my answer. So my final answer would be 5a squared plus 11b squared plus b minus 6. Okay? So you are combining like terms, putting them in descending order of exponent. Okay? All right, the last thing I want to go over is something called the distributive property. So the distributive property here, I have a 2 outside of parentheses, and I'm going to distribute that to everything inside of my parentheses using multiplication, because we know number outside a set of parentheses means to multiply. We are going to use something we call the distributive property. So watch what I do. So I'm going to distribute that 2 to the a and to the positive 2a squared. So I am going to take 2 and multiply it by a. 2 times a gives me 2a. Now I'm going to multiply that with the 2a squared. So 2 times a positive, this sign gets associated with this 2a squared. So a positive 2 times a positive 2a squared gives me a positive 4a squared. And then I would drop down my plus 2b. So now I'm looking, is there anything that I can combine? Well, I have 2a, 4a squared, and 2b. Well, I have 2a's, but this one has an exponent of 1, and this one has an exponent of 2. So those are not like terms. I cannot combine them. So there isn't anything I can combine here, but my final answer should be going in descending order of exponent. So my largest exponent should be going first, okay? So, and I'm taking the sign with it. So this 4a squared is positive. So 4a squared followed by a positive 2a, and then followed by a positive 2b. So your final answer would be 4a squared plus 2a plus 2b. Okay? All right, that is it for today, and I will talk to you guys soon.